There has been a marked increase in obesity over recent decades, such that up to 200 million school-aged children across the globe suffered from weight problems in 2010, according to the International Obesity Task Force. This surge in obesity is not simply a problem of aesthetics. It is associated with numerous serious health problems later in life, such as cardiovascular disease and type 2 diabetes and an increased risk of cancer, as well as having a massive financial burden on society as a whole. Even more worrying, the situation is becoming worse and worse, with over 1 in 2 infants born today destined to become obese later in life if current trends continue. Hence, it is easy to understand why the WHO describes obesity and obesity-related diseases as one of the most serious public health challenges of the 21st century, and why obesity prevention is such a pressing cause. It has emerged that we are not all born equal in the face of obesity. Infants are more likely to have weight problems later in life if their mother is overweight or obese, if they weigh more than 4 kilograms at birth, if they gain weight rapidly in the first months of life, or if they are not breastfed. So given the huge number of women of childbearing age who are overweight or who choose not to breastfeed, we can see that an enormous number of infants are at elevated risk of overweight or obesity later in life. It is in this context that scientists focused on finding out how breastfeeding protects infants against obesity later in life. One key factor appears to lie in its protein content. According to the so-called early protein hypothesis, a high protein supply in infancy is linked to increased adiposity in childhood. A possible mechanism is the increased secretion of insulin and insulin-like growth factor IGF-1 caused by high protein intakes. Several studies, especially the European Childhood Obesity Project, have lent support to the early protein hypothesis, confirming that high protein intakes in infancy cause faster weight gain and higher BMI in the first years of life. Now let's look at how the protein provided by breast milk changes during this period of time. We can see here that thanks to the changing, that is decreasing protein content of breast milk in the early months, the amount of protein that breast milk provides closely matches the infant's requirements. As the infant growth velocity slows, the protein concentration of breast milk drops and the protein intake provided to the infant declines. In this way, the protein provided by breast milk always matches the infant's protein needs very closely. Now let's have a look at current standard infant formula. How much protein do they contain? Unlike breast milk, infant formula do not change in composition as the infant gets older. Therefore, after the first 1 to 2 months of life, most formula provide more protein than infants need, and we call this excessive protein intake. Formula for older infants, instead of providing lower protein intakes, currently provide higher protein intakes than starter formulas, thereby further increasing the gap between protein requirements and intakes. This ultimately means that unlike their breastfed counterparts, formula-fed infants receive excessively high amounts of protein in the critical first year of life. A first study carried out in Chile involved over 250 infants known to be at elevated risk of late obesity as their mothers were overweight or obese. At 3 months, formula-fed infants were randomly assigned to either the new infant formula with a reduced protein content of 1.65 grams per 100 calories, or to a standard formula with a considerably higher protein content, namely 2.7 grams per 100 calories. Breastfed infants served as a control group. This clinical study confirmed that this new lower protein formula, fed from 3 months to 1 year of age, is safe, with infants who received this new product having similar weight curves to breastfed infants. In addition, they weighed a full 518 grams less than infants who received the higher protein formula at 2 years of age, in other words, 1 year after the end of the intervention period. A similar beneficial effect up to the age of 2 years was also seen on BMI, with infants who received the new lower protein infant formula from 3 months onwards having BMI close to the BMI of those who were breastfed. Other growth parameters, like head circumference and length, were perfectly normal in infants who received the low protein formula. Very interestingly, all of the beneficial effects of this lower protein formula persisted for 1 year after children had stopped taking the low protein formula, suggesting a long-term effect on healthy weight development.